Hey everybody, this is Dr. Rindy, and I want to thank anybody who's joining me right now from the webinar I did earlier with Lake Washington Physical Therapy on the microbiome. I just wanted to record a quick segment to go deeper into the topic of intestinal permeability, as I feel like this is needed for further understanding. So just to kind of review a few things I talked about is the small intestinal mucosa and the large intestinal mucosa have different properties and different functions. And the environment in the small intestine, which is the 25 or so feet that's north of our colon, has a different function and purpose and versus a large intestine. So let's talk about the small intestine. It's largely comparatively a microbial-free environment. So what we see is a lot of emphasis by the immune system of keeping it sterile. So there's a release of antimicrobial peptides. The commensal bacteria count is very low. There's more surface area available for digestion and absorption. The environment is meant to feed us, and so the immune system works really hard at keeping the area sterile. Some microbes might play a role in some properties of digestion, but it's really meant to have one single mucus layer protecting the cells, and the rest of it is kept sterile for digestion and absorption of protein, carbohydrates, and fat. The large intestine, on the other hand, which is the last 5 or so feet of our digestive tract, has an inner mucus layer and an outer mucus layer. The outer mucus layer is kind of loose and filled with billions of bacteria, and these are all considered friendly bacteria. And the goal of the immune system in this part of the intestine is to detect problems when you need to, fight pathogens when you need to. However, the goal is to keep that microbiome alone, keep that microbiome alive and protected from the immune system. So we have a double mucus layer. One part of the mucus layer is relatively sterile. There might be a few a few microbes that might cross into the inner mucus layer and live there normally and be involved in house cleaning. However, for the most part, we are looking at a sterile environment. So this particular part of the intestine is used for postbiotic production of short-chain fatty acids. It's involved with producing B vitamins. It's involved with water reabsorption, and that's its main function, and obviously, to finish the digestive process. So we have a lot of players in intestinal defense that can help with immune function. The goblet cells, Paneth cells, goblet cells are involved with secreting mucus, and the lymphocytes are involved with something called secretory IgA. The lymphocytes in the epithelial layer are involved with secreting what are called beta defensins and Reg3. Just to kind of back up and clarify something, the secretory IgA, which I should have said is secreted by the plasma cells, is involved with trapping pathogens that are in the environment and are a really important part of our immune system. Dendritic cells are involved with going through the intestinal gaps and checking for pathogens. And so you can see in this picture, the dendritic cell is reaching up and finding this motile bacteria that looks like a pathogen and basically tasting it, and then it will come down to the immune system and program cells to be ready to fight it in case it's starting to cause problems. Paneth cells are another cell that secretes lysozymes to kind of break up pathogens and help the immune system. So we have a lot of defense that's going on for our benefit in the intestinal lining. This is just a nice picture of the small intestine, of kind of a real view of the small intestine. Up top is the villi that are involved with absorption, and below you can see muscles that are involved with propulsion of contents through the intestine. And the villi protect us from larger molecules and from bacteria getting across the walls. And in the gray area is blood vessels and lymphatics that are involved with transport of nutrients into our body. In the colon, you can see the surface area is really designed for water reabsorption, and the mucus is designed to kind of keep bacteria out. We have these large, what are called columnar epithelium, and so we absorb our postbiotics like short chain fatty acids and water in that area primarily. So when problems arise, there'll be defects in the mucus layer or the mucus quality, and bugs or environmental agents can poke holes in that barrier and basically get across. So if you think about the defense system of the gut, then if this particular barrier is breached, then the immune system goes on an alert, a danger alert. And for the most part, the immune system does an appropriate job of keeping this kind of balanced. But if this offending agent continues, whether it's truly harmful or not, the immune system can become upregulated, and we have what's called a break of tolerance, or we have tissue damage, chronic inflammation, allergies can develop. For the most part, the body tries to use what are called T regulatory cells to counter inappropriate inflammation, but this system can be upregulated and is the main link for these chronic illnesses that are associated with microbiome problems. So we see here on the left an appropriate response where the immune system is protecting our microbiome and not causing an overactive immune response through the use of dendritic cells that are telling the immune system on the left to secrete anti-inflammatory molecules like IL-23, IL-22, and IL-10 to just tone down inflammation because the system is fine. On the right, we have an issue. We have a yellow rod bacteria that's kind of signaling the dendritic cell that there's an invasion going on into the internal world, and then all of a sudden the alert happens. Dendritic cells are upregulated, IL-17, IL-22, IL-23, INF gamma, and we have the immune activation. So this is something really important to understand, is that there's a lot of factors that can be linked to intestinal permeability. This is a pretty comprehensive list. Pathogens can cause intestinal permeability. Some of them you're probably familiar with, like Campylobacter jejuni, which is when you get food poisoning. Nutrients, having extreme ends of high amounts of nutrients like high fats can cause intestinal permeability, or high carbohydrates. The deprivation of certain nutrients like vitamin A, vitamin D are involved with potential intestinal permeability. Certain food additives, emulsifiers can contribute to intestinal lining issues. Drugs like PPIs and anti-inflammatories can also contribute. Toxins in the environment from bugs and from other sources can contribute. Allergens like peanuts, soy, wheat, milk proteins can all be involved. Stress, as I've mentioned in the webinar, is largely associated with causing permeability issues through cortisol signaling, vagus nerve problems, as is hypoperfusion, as I mentioned in the webinar, from overtraining. Even obesity can lead to low circulation in the intestine, which can cause permeability issues. And so when we have this gut-related damage, it sets on this cascade of inflammation problems. So it triggers something called toll-like receptor activation, and this can trigger an inflammasome activation, which leads to activation in the innate immune system, NF-kappa beta, INOS, nitric oxide, COX-2. These are all inflammation that can be upregulated once that immune system goes on alert. If it's not counter-regulated or if it's not handled, then we can have other pathways that lead to chronic organ problems, pain, inflammation, insulin resistance, brain inflammation, sometimes the development of autoimmune disease. So it's really important, whatever we do, is to look at these factors that can damage the intestinal lining and really be mindful of protecting that part of our body. It is somewhat of the intestinal lining is somewhat of the holy grail of disease. We just really need to take care of it. And that's, one of the main takeaways that I wanted to give you from the webinar. And thanks for tuning in. And if you have any questions, please feel free to get in touch with me. Thanks.